students. Welcome to one more session of your WOC, that's your 200 most expected question series. Right, I'm back again with more important questions of your organic too, as most of the students were asking me to send organic questions. So I have really collected important questions and I've brought it in front of you. Please watch the complete video, and I request students, more and more you share, more and more the knowledge would reach the students who can't really, who can't pay and achieve that. So I request all the students to share this video as much as possible. Let's start off, students. And important thing, I have kept a playlist for most expected series question. In that, all the day-wise questions are there. So take a notebook, note it, write it down, and keep practicing it, students. Right, let's start off with the question. Let's see the first question today. What is it? Right, see this question. This is basically whenever you're studying ethers chapter, this particular question on Williamson ether synthesis, compulsory one question would be there. Let us read the question, students. Right. Write the names of reagents and equations for the preparation of the following ethers by Williamson ether synthesis. Right. Basically, this particular question is from alcohols, phenols, and ethers chapter. What is the question? I have to prepare the following ethers. Basically, I need to prepare 4 different ethers, and that too, these ethers I need to use which one? By using Williamson ether synthesis. That's the concept. Okay. So when this question is given to you, what are you supposed to do, students? You need to, let me take the next slide. Understand carefully. So the first question number is, okay, let me take a white pen for you all so that it's clear. Right. Okay. Now check, students. First thing, I need to prepare what? 1-propoxypropane. So you need to first write using Williamson synthesis. Copy the question like this. I have to prepare what? Prepare 1-propoxypropane. This is what I need to prepare. Okay. By using what, students? By using Williamson ether synthesis concept. Williamson's ether synthesis concept. I need to use this ether synthesis concept. So what is this concept, students? Basically nothing. In Williamson ether synthesis, I am going to take one alkoxide, correct? You're going to take one alkoxide. And that too, you're going to use
Unacademy, the biggest online platform, learning platform in India. Let's crack it. I'm Vani Potepalli, the verified educator for grade 12 students, CBSE, ICSE as well as state board students are with me. Ace your final exams with Unacademy Plus students. So you'll be getting a flat 10% off only in this month. That's till February 28th. Note the date, students. There's a new feature with Unacademy, that is Ask a Doubt feature. So here is a procedure, students. Step 1, go to your Google Play Store. There, download the Unacademy Learning app. Then, as soon as you open, you get started, give your mail address or the mobile number, whichever is possible. Next step, once you enter there, your Unacademy mail ID, enter, go to continue. Select your residence, where you're staying, which state. You get an OTP to your mobile. After that, search for the goal, grade 11 or grade 12. Select your language of preference. Then you would get an option, yes, welcome bonus of almost 200 credits earned. That's a additive to your account. Then you can directly go, you have the scrolling as you see. There's an Ask a Doubt feature over there. Simple as that. Enter the code, right? There's an invite code asked. Then you can click it. Yes, you're ready to get your doubt solved. What should you do, students? Wherever you have doubt, first important thing, take a picture or choose it from the gallery. Then comes your step 2, cropping the picture. Then comes your step 3, either uploading or submitting your question. Step 4, as you know, once you send, students, how many of our unlimited doubts are there? Whether it is in maths, physics, chemistry or biology, select the subject which you want your doubt to be cleared. Then you can just type, right, I have a doubt. Can I get the solution? It's already there, uploaded, you sent it, you have sent it, cropped it. So automatically you get your doubts cleared from your educators. Right, students, instantly, n number of doubts, both in English and Hindi. Easy? Yes, students, follow the steps all and you get the solution instantly. Right.
I'm also there taking PYQ batches for science students. That's previous year's questions that is going to start off that on almost in just 2 days. And Unacademy subscription features are these students. You can join for a personal mentor where you can get all your 360-degree support system. These are the prices, Unacademy subscription prices students for both grade 11 and 12. Plus also is there, Iconic also is there if you wish to join me. And remember students, this is my referral code Vani Life. Remember Vani Life or Vani 10. You can use both the codes for 10% discount. And students, easy, download the Unacademy app today through Play Store. And you can use my referral code to join the session and get 10% discount. Use sodium. So you're going to use sodium alkoxide. Along with that, you're going to add one alkyl halide. This alkyl halide can be primary, it can be tertiary. We are going to see the different cases. Or sometimes alkoxide also can be tertiary. We will see. So this is the concept. And finally, what do you get here? You will be getting an ether. Let's take this. What is the first case now? 1-propoxypropane. Write the formula as soon this is given to you. Propoxypropane. How does it look, students? 1,2-propoxypropane. Two sides along with ether. Oxy group is there, no? So CH3, your CH2. Now this is one prop. Oxygen in the center. Again, you have the groups. Okay, students, what is this? This is called 1-propoxypropane. Now easy students, very easy. Nothing to get confused. Once you have written the formula, now count the number of carbons here. 1, 2, 3, 1, 2, 3. Total number of 6. So I'll divide these 6 with these 2. Right? Now, sodium alkoxide. Do one thing. Write all the 3 on one side. Take your sodium group. This is your alkoxide. How many else are there? 3 are over here, no? 3 more you're going to take with your alkyl halide. This is also over. Now you're going to add one bromine. Correct, no? Alkyl halide. Now, as usual, 3 hydrogens, 2 hydrogens, 2 hydrogens. That is always there. That is understood, no students? Right. Now check carefully. 3 plus 3, 6. 3 plus 3, 6. Correct. Now what is going to happen, students? Minus NaBr. This NaBr is out and I get minus NaBr and you get the required propane. Easy. So 1 alkoxide. What is this? This is called sodium propoxide. What is it, students? Sodium propoxide. Sodium propoxide. What is this called, students? This is 1-bromopropane. 1-bromopropane. Nothing. I just added both. Using this concept, I got the compound. Easy. Let us do the next one. 2-methyl 2-methoxypropane. Okay. 2-methyl 2-methoxypropane. The second one. I need to prepare what? Right now. Let us write the compound first. Always write the compound. 2-methyl 2-methoxypropane. Correct, no, students? This is what I have to prepare. What is the formula? Okay. They said there is methyl group at the second carbon. There is methoxy group also in the second carbon. And the parent chain is propane. Write down 1, 2, 3. This is prop. Now, this is the first carbon if you take. Okay. Second carbon, let me consider this. In the second carbon, I have one methyl group. In the second carbon, I have one more methoxy group. Right, students? This is also there. This is so. This is the compound. So I have to prepare this 2-methyl 2-methoxypropane. This is 2-methyl 2-methoxypropane. Now go back. What should I do? I have to add one alkoxide and I have to add one alkyl halide. So always remember, students, whenever you are getting or you are given a tertiary alkoxide, means a compound like this, tertiary alkoxide. So the phenox or the alkoxide which you are taking should always be tertiary only, the bulkier groups. Again, once again, students, if you are given a product where you have tertiary group, this is your tertiary group, no, students, then there is an oxide also, alkoxide. So you should take a tertiary, prefer a tertiary alkoxide as a base reactant. Okay, now this one, right? You're going to combine with bromine. Now how many are over? 1, 2, 3 are over. Here also 3 are over. How many are left? CH3. That's all. Now take out NaBr. So you should remember this. That is minus NaBr. And I get the product. Now what is the logic here? Whenever you're getting a tertiary bulkier groups here, the alkyl halide goes with the less bulkier groups, that is your primary, methyl, and the alkoxide will be formed by a tertiary group. Got it? So name this compound, students. This compound is nothing but sodium 2-methyl. Okay, sodium 2-methyl. Okay, as sodium is there, 2-methyl is here. What is more there? Okay, then 2-propoxide. Sodium 2-methyl 2-propoxide. Got it? Now what is this, students? This is nothing. Bromomethane. So you need to write all the compounds. So I think it's clear. It's clear, students. Let us do the next one. So first one is this. Second one, this is over. Now ethoxy benzene and 1-methoxyethane. Ethoxy benzene shall we see now? Third one. The third one is I have to prepare what? Ethoxy benzene. Write down ethoxy benzene. Okay. Write the formula of ethoxy benzene, students. So your benzene is here. You have ethoxy, oxy O and C2H5. This is your ethoxy benzene. Again, same story I have to take. Now what should I remember? As I said, when you have bulkier groups asked in the exam, the alkoxide is formed by the more bulkier group. The alkoxide is formed with the more bulkier group, and the alkyl halide will go with a smaller group. Smaller group. The halide with the smaller group, alkoxide with the bulkier group. Now take out this Na. Take out this Na here. What do we get? Minus NaBr. That's all. Simple. So simple as that. You should remember which should be the bulkier group. Last one, students. What should I prepare? Yeah, I have to prepare. Yes, check carefully. They asked me to prepare methoxyethane. Let us take the last one. I have to prepare methoxyethane. Okay, methoxyethane. Now you check, students. Methoxy is also there. Ethane also is there. Write the formula. Eth. Okay, CH3, CH2. Oxy, oxygen. Methoxy. This. I have to prepare it from how many? You only tell me now. There are two carbons on this side. There is one methyl group on one side. Simple. Write down. You're going to take the alkoxide with this, with a bulkier group, and you're going to add the alkyl halide with the smaller group. So take out NaBr from here. You're going to take out and you get NaBr. That's all. Easy, isn't it, students? Right. So this is the logic how you should perform or do the reaction. Only thing you have to remember, whatever is a compound, try to write the compound, and you're going to see what is the alkyl halide, which one I should take. If it is a bulkier group, try to take the alkoxide with a bulkier group, right? If it is a smaller group, no problem only. You can equally divide, but remember to check with that. Okay. Next question, students. Nice. This is the big question. Let's understand this. Here they have given me a question. Identify A, B, C, D, E and F. A, B, C, D, E and F. I have to identify all that. They have given a reagent based on the arrow. That explains everything. Let's start off, students. First, what did they do? They have taken phenol. They have heated it and they're treating it with zinc. So whenever you're treating with any metal, what will happen, students? The reduction. Perfect. After that, you're doing or treating with nitrating mixture. What will you do? You will get nitro group entered. Nitro group as an electrophile will enter. Then you are taking bromine, nice. Nitro group is meta directing. It will go to meta position. Okay, I'm understanding clearly, no? Right. After that, you are treating with H, means hydrogen, and vanadium and platinum. Okay, vanadium, platinum. Again, this is a reducing agent. Nitro will get converted to amine. Then what you are doing? You are treating with HNO2. Amine gets converted to BDC. BDC to this. Oh, easy. Now I'll start doing the reactions. Let's start. I'm going to take the first part, students. What is the first part? The first part, phenol is treated with, it's treated with Zn and heat. This is a reducing agent. What will it do, students? Zinc with oxygen comes out and the hydrogen drops in, and this is the conversion of phenol to benzene. Simple. So this is your phenol compound and the compound which is formed, because this will do which process, students? It's going to help reduction, addition of hydrogen. Addition of hydrogen will happen. Phenol was there, no? So I get. Now what is this? This is benzene. Then this is your molecule A. Now what did they do? They treated this with what? This is over. HNO3 and H2SO4. Okay. I'm going to take benzene and I'm going to treat it with a nitrating mixture HNO3, H2SO4. What is this, students? Basically, this is a nitrating mixture. What is the electrophile it adds? NO2 plus. Now take that, add it. So you're going to take benzene and you're going to get nitrobenzene. Correct? Nitrobenzene is which product? Now this is compound B. This is nitrobenzene. Nitrobenzene over. Now first A and B are over now, students. I got A, I got B. Now I'm going to take B. I'm going to take B. Now what did they do? They have taken that B and they have treated it with bromine. Now you very well know, students, you very well know bromine. What happens? What happens? This nitro is meta-directing. It will direct this bromine to the meta position. Remember. So I'm going to get NO2. I'm going to get meta-bromine. What is this? This is meta-bromo-nitrobenzene. Meta-bromo-nitrobenzene. Correct, no, students? Meta-bromo-nitrobenzene. This is which compound? This is compound C. Now what am I going to do? Let me see next slide how many I have. Okay, I have only one slide. I'll use it here only and explain. I'm going to take this C and what I did, I have added hydrogen in the presence of vanadium and platinum. These are reducing agents, students. See here, metal are always metal catalysts reducing. They're going to add or they perform reduction. Zinc, what happened? Added hydrogen. Platinum, vanadium, reduction. What will happen? Oxygen is gone. Hydrogen is added to this. What do you get? You will be getting a compound that's nothing but NH2Br2. This is my compound D. And what is the name of this compound, students? Meta-bromoaniline. Very good. This is meta-bromoaniline. Clear now, students? Okay. Now the compound is what? This is D. D is over. Last. So what are there in this? A I got, B I got, C I got, D I got. Now I'm going to take D and do the reaction. This is a compound D. That's nothing but aniline plus Br2. I'm going to treat this D with what? HNO2, nitrous acid. So simple, students. Whenever you're treating with nitrous acid, aniline gets converted to BDC. Correct, no? Aniline gets converted to BDC. What do you get? Aniline to N2Cl and your bromine. Got it? Now this is your compound D. Name this compound, students. Let us write the name here also. This is meta-bromoaniline, right? What is this compound, students? Meta-bromo, yeah, benzene diazonium chloride. Benzene diazonium chloride. Meta-bromo benzene diazonium chloride. What is this compound, students? E. Last. I'm going to take this E and I'm going to treat it or do H3O plus in the presence of hydronium ion or the acidic medium. What is going to happen? This nitrogen gas escapes out. Nitrogen gas escapes out. Your HCl comes out with this and the leftover, what happens, students? You're doing acidic medium. So the BDC part gets converted to phenols. The BDC part gets converted to phenols. This is my last product, nothing but F. What is the name of this compound? Meta-bromophenol. What is this, students? Meta-bromophenol. Perfect. Now check, students. I have got all or not. Let me once cross check because in the exam I should not miss A. Where is A? Yes, A is here. B is here. Okay, let me take, yes, A and B. Then C is here. D is here. Then E is here, F is here. All are there, students. A, B, C, D. So finally, I don't have place here. That's why I'm writing. In the exam, you're going to write like this. A, B, C, D, E, and F. Write the compounds. You'll get full marks for this. Right. Let us see the next question, students. Yes. Complete the following. They have given one question, complete the following. Easy question, nothing to get confused. So this question, what does it mean, students? They have given phenol, they ask you to find this reagent. Simple. What are you finding? What is the difference, students? You have added this aldehyde group. What is that reaction, students? Simple. Yeah. Riemann-Tiemann reaction, you know? Yes. What should you do? Nothing. Preparation of this from phenol, you're going to take that, write CHCl3 in the presence of NaOH. What Kelvin? 340 Kelvin. You're going to prepare this compound. When you see phenol combination with aldehyde, nothing. It's basically, what is the name of this compound, students? It is called 2-hydroxy benzaldehyde. 2-hydroxy benzaldehyde. Right, students? Easy? Right. So that's nothing but your CHCl3 and NaOH. Now you tell me this reaction. Both are related, almost. Both are related. Have you got this idea? Yeah, students? Something like Kolb's reaction. Something like that? Yes. When you're treating sodium phenoxide, okay, you need to only write the product. No other steps with carbon dioxide at 373 Kelvin, 6 atmospheres. You remember, students? Yes, this particular thing, I'm not writing the complete reaction. It's going to get converted to a compound, nothing but 2-hydroxy sodium benzoate. 2-hydroxy sodium benzoate. Got it, students? Simple as that. So what did we do? We have to, before I go to the next question, what did they do? They have taken that compound, they have asked me to complete the reaction. So I saw the reaction conditions and I automatically wrote the product. Last question, students. Let's see this. What happens when phenol is treated with methyl chloride in the presence of anhydrous AlCl3? Okay. Earlier, name reactions are given like this. Okay. Then they'll ask you questions like what happens. So it seems they have taken phenol, they have treated it with methyl chloride in the presence of anhydrous AlCl3. Simple question, students. What did they say? Methyl chloride plus phenol. Okay. We'll take phenol. You are going to take methyl chloride. Methyl chloride is not chloroform. Earlier was chloroform. So this is anhydrous AlCl3. Now anhydrous AlCl3 is a Lewis acid. Correct, no, students? Lewis acid, it's going to gain this electron. So this will pick up this chloride. What will happen? There is a cleavage of the bond and this methyl group goes and attacks this phenol here at the ortho position. You get OH and CH3. And it also goes and attacks at the para position because of the resonance. You get one more product that's nothing but OH and CH3. That means nothing, students. Understand? When phenol is treated with methyl chloride in the presence of anhydrous AlCl3, you will get two products. What is that? One compound, because of the resonance, orthomethyl phenol, not methoxy, orthomethyl phenol plus paramethyl phenol. Nothing. To confuse you all, to test you all, they have given in the form of sentence formation. That's all. Okay, simple. This is which type of reaction, students? It's nothing but Friedel-Crafts alkylation reaction. Correct? No? Friedel-Crafts alkylation reaction. That's alkylation reaction. Okay, done. Now let us do the next one. What did they say? Let us read the question. Phenol is treated with benzene diazonium chloride in the presence of NaOH. Okay, phenol, it seems they have taken the benzene diazonium chloride. Let us take that. I'm going to take phenol. Okay. So phenol, can I write it like this? OH and your hydrogen one side. So, correct? No. Right. Now one more side, I'm going to take benzene diazonium chloride, that is BDC. N double bond NCl. This is what, students? This is benzene diazonium chloride. What is this compound? This is phenol. Now nothing, what are you going to do? This is Cl, no? This is Cl. You are going to take this HCl out. You are going to take out that HCl. Right. Now see here, in the presence of NaOH you said. In the presence of a base. Now what is going to happen? Your HCl comes out, minus HCl in the base, in the presence of a base, and these two compounds are going to join. Okay. There's a name for this reaction also, students. We will write that. Okay. Join nitrogen, double bond, single bond, and you're going to attach this phenol ring is there, no? The phenol ring and your OH. And HCl anyhow is here. Now what is this compound, students? This is called, see here, hydroxy group is in the para position. This is called para-hydroxy azobenzene. Para-hydroxy azobenzene. Ma'am, what is this reaction called? Yes, yeah, this is called coupling reaction, students. What is this called? Coupling reaction. Coupling reaction where you're going to take BDC, you're going to take phenol, and you're going to get a product. So what is this? 4-hydroxyazobenzene is an orange color dye. Orange dye. Okay, right? Okay, simple. Now students, the next reaction. The last one, what did they say? The last one they said, you are going to prepare. Let us see the question once again. Okay. Benzene, this is also over. No. Phenol is treated with phthalic anhydride in the presence of sulfuric acid. Wow. Sulfuric acid is nothing but a dehydrating agent, students. What it seems? They have taken phthalic anhydride. Phthalic anhydride, I think you remember, you have learned in Gabriel phthalimide synthesis. Yes, this is your phthalic anhydride. Got it, students? Got it. I'm treating this with phenol. Okay. Now what will I do? I'll write phenol little bit below. Okay. I'm going to write phenol to show you the reaction clearly. I'm going to write phenol. One OH here, one H here. One more. Okay. One more. I'm going to write OH here. I'm going to write H here. Because they have treated with phenol. Now simple, students. See here how I'm taking out. I'm going to take water molecule from here, H2O. Which one is doing this work? Concentrated sulfuric acid is doing this work. Okay, so maybe the place is not sufficient. I'll write it in the next place. Concentrated sulfuric acid is a dehydrating agent. So it's going to give me a product, dehydrating agent. See this product, students? The product I'm going to write in the next page. Check. I'm going to get a compound, simple one. The phthalic anhydride C double bond O, oxygen is there. That carbon is there. No? See here. This carbon is still there. Only oxygen has gone. This carbon is going to join with two rings. The phenol rings are there, no, students? Phenol rings are there, isn't it? Yes. Those phenol rings. This is the next. Got it? Right. Plus water molecule is already out. Now this, what is the name of this compound? I think students would have known. This is called phenolphthalein. You remember, students, phenolphthalein indicator is used for knowing whether it is an acid-base indicator. Correct, students? So this phenolphthalein indicator is prepared when you are treating phthalic anhydride. Let me write that. This is nothing but phthalic anhydride when you're treating it with phenol. You're treating with phenol. That's all. Simple. So I did the most important reactions of phenol, right? So I did almost, 3, 6, almost 8 or 9 questions I did today. So please watch the whole video. Thank you so much for watching. Please share the video with your friends so that I'll come back with next question. Thank you so much, students. If you are watching this video, I'm really thankful for that. But if you are not showing interest, even I lose interest, students. So thank you so much for watching. Meet you again in the next video. Bye-bye. Take care, all of you. Keep smiling. Right. Bye, students. Thank you.